A very good morning to all of you. So, welcome to the my class. So, today we are just going to start from where we left
Good
yesterday.
morning, sir.
Okay. So, let's see. We were discussing about the relative velocity in one dimension. Okay, and we discussed. We were discussing about the graphs. Okay, we have discussed so far the two graphs. Okay, so let me start from there only. Okay, so I'm just sharing screen, and you can see here. Okay. Please, when you enter in the class, kindly mute yourself. Otherwise, I will do settings. So you will be muted all the time. Okay. So these were the two cases. And what were these two cases? If relative velocity means v2 minus v1 was 0, means this was
Good
v21.
morning, sir.
Morning to all of you. Yes.
Good morning, sir.
If this was the case. Morning. So the graph was like this. This was the position is going to, but the you can see the velocity. That's why if it is position, it is time, and it is, let's say, x1 of t, and it is x2 of t. So in this case, both having same velocity. So relative velocity of these two are 0. Okay, both are moving in same direction. And in another case, we discussed that graph, this was something like, no. Okay, this was the another graph.
Yes, sir.
So I have discussed this one. So basically, this was
Good
graph.
morning, sir.
This was your position, and this was your time. In this case, if I am saying that this is 1 and this is 2, in this case, if we are willing to calculate, or you can say mark it 2 and this is 1. So this was the case of V21, where you were writing V2 minus V1, and this V2 was greater than V1 in this case. Okay, so this was the case, and this is, you can say, the position of this x2 is there, and this is position x1 is there, and this is position time graph. So we have discussed so far these two graphs. From these two graphs, we can conclude that in first case, these bodies are not going to meet each other in either condition. किसी भी condition में ये कभी एक दूसरे को मिलेंगे नहीं. The distance will be remain same. Okay, whatever the distance will be there, that will be remain same. These were the case when bodies were moving in same direction. Okay, so these graphs were for the when bodies are moving in same direction. So this was the case for the same direction. Okay, so if we are talking about the third case, in third case, what we'll see here, so these were the case when V21 means this is going to 0, and in this case, this V21 is going to be greater than 0. This was your first case, this was your second case, and this was your third case if you're writing like this. This is third case. Now what we are, what I am writing here, just see it. You can write like this, or you can understand in a way like this. Let's say this is position, and this is your time we were discussing. Okay, and I am saying that this position, this particular object is moving like this. Okay, and this is moving, this person is moving like this. Okay, now you can see what you can see. Let's say this is your, means this is second person, and this was your first person. Okay, so you can see here, this was the position of x2, that is 0, and this was position of x1 at time t is equal to 0. Whatever position was there, you can see now, if you are writing like this velocity of 2 with respect to 1. So you can see here the velocity of 2 is lesser than v1 because the slope of this graph, you are seeing this one, this is the basically slope. Let's say this is theta 1. And in this case, if you are saying that this will be the slope, this will be theta 2. So which one is lesser? Theta 2 is lesser now. So velocity will be greater for which having a greater slope. So in this case, if we write here v2 minus v1, so it will come negative. Means you can write like this, v21 is less than 0. So in this case, this is the point. This is the point where the first person is going to overtake the second person. Okay, this is the case when first person is going to overtake the second person. Now the distance between these 2 points will be 0 at this condition. Here there was some certain distance at time t. Let's say this is at time t. This is at, let's say, time t. These will be meeting each other, or means you can say the first person will be overtaking the second person. So if I can take the example in your terms, let's say Kutub and Subham are there, and Kutub means Subham just start going to the school from his home, and Kutub also start moving towards the school, but Kutub was behind the you can say the Subham, but Kutub start means just increases his speed. So the time will come when he will just cross the Subham. Okay, so this is the time. So at that time, the relative distance will become 0. So you can see like this. If you are saying that this x2, this x2 at a time t minus x1 at time t will be 0. Okay, so this is going to be 0. It means what? It means what? So this is the point at from the origin, this will be the distance. From the origin, this will be the distance, but the relative distance will be 0. Okay, the relative distance will be 0, and this is the time of meeting when they will be meeting each other. So this can be, so this can be written as, this x2 can be written as, what x2 can be written? If its velocity is v2, so this will be your, you can say the t. Okay, and if you are saying that this velocity of this person is, let's say, v1. Okay, so the thing is that it is starting from here and is starting from here. The starting point for the both objects are different, but the speed is also different, but the relative distance will become 0 once they will be here. Okay, because let's say, you can take the example in another way. Let's say these are the cases. So this is the basically, this was your you can say this was the first person and this was your second person. Okay, this was at time t is equal to 0. This was the case when time t is equal to 0. Then there was certain distance, let's say delta x was there. Okay, at time t both will be at the same point. So but after certain time, this one will move ahead to the b. Okay, so this is the case. So this is the case while when means one first person having greater velocity than the second. Okay, so these were the three cases that I was discussing about when objects are moving in same direction. Okay, let's discuss when objects are moving in opposite direction. What will happen in that case? So should we move to the next page?
Yes, sir.
Yes.
This is the case when
Good morning, sir.
morning, Kutub, you are joining late. When objects are moving,
13 minutes
सर
late.
आज लेट हो गया सर, सॉरी सर.
when objects are moving in opposite direction. So in this case, so it is compulsion that these are going to meet each other. Okay. So if you are saying like this is the condition. Let's say this is first person who is moving with velocity v1, and this is the second person that is moving with velocity. This is second person. This is moving with velocity v2. And if you are willing to draw the graphs of these two, so once again I will say what you need to choose is this sign convention. In this direction, you have to take the positive, and in this direction, you have to take the negative. So if it is, let's say, position, and this is time. So which velocity you are going to take negative? This v2 will be taken as a negative now. So this will be the second person. Will be moving like this because the slope of position time graph is negative. So velocity will be negative. So this is your v2 means position of x2, and the velocity is you can say v2. And in another case you can see like this is the case, or you may start from here. Okay, so this is the case, this is a position of x1, so this is first body and its velocity is v1. So at this point they are going to meet each other. Okay, at this point they are going to meet each other. If you are saying that velocity of 2 with respect to 1, you will write like this v2, and the v2 will be taken as a minus this v2 minus v1. And if you are saying that velocity of 1 with respect to 2, so you will write here velocity of 1 minus of minus v2, so it will be your so plus of v1 plus v2. This is the case. Simply, this is the case. Okay, I think you got my point. Is it clear to all of you? Okay, have you done it?
No, sir.
Yes, sir.
Yesterday you had given this, sir.
Pardon?
Yesterday you had given this.
I'm not getting you what you are saying.
Sir, you have taught these things yesterday, sir.
So we didn't discuss the graph.
He is saying that you have taught.
No, so we didn't discuss this graph, na? That's why I'm. Yeah, we discussed these things.
Yes.
We didn't go to this graph. Okay.
Yes, sir,
Yes,
graph
sir.
not discussed.
So we'll have some bunch of questions. Okay, on the topic of these whatever we have studied till now. Okay, the chapter 3 is completed. I don't think there is any topic which has been not taught by me. Okay.
Complete.
So very soon we'll be starting the next chapter, that is motion in a plane. Okay, this was all about the motion
Complete.
in a plane. Okay, so we are just going to have some bunch of questions on the basis of these topics. Okay, so then we'll move to the motion in plane. Done.
Yes, sir.
Should we move to the next page?
Yes, sir.
Okay. So please mark your presence by writing present in the chat box. Okay. So this is the case what we are going to discuss. Yeah, the question is that draw the velocity time graph for an object thrown upward with some velocity and return back to ground back to ground after certain time. And another question, that we are going to discuss. First, discuss this one. Okay. So, can anybody let me know how the graph will be? How we can draw the graph for this? Yes. Yes, Aryan is there.
Yes, sir.
Yes. Have you got the answer? Means, have you got the graph?
Yes, sir. Yes, sir. It's like a triangle, sir. So first the velocity
Maybe
is
like this, sir.
increasing.
Sir,
After some
maybe
time
like
it will
this.
decrease.
It will be like this.
Yes, sir.
But
Yes, sir.
it's wrong. You know.
Sir, like a downward facing parabola.
Yeah. Means inverted triangle. It will be like a inverted triangle. So whatever you made, that will be opposite to that graph. Why it is so? Let's discuss. Okay.
Okay, sir.
Okay. Let's see here. If you are saying that draw the velocity time graph for an object thrown upward with some velocity and return back to ground after certain time. So what you can say, you are having certain velocity at time t is equal to 0 because this object is thrown upward. Okay. So at t equal to 0, you have a velocity that is your initial velocity. It will have or not?
Yes, sir.
And as time increases,
Yes, sir.
velocity is going to be decreased. Once you throw this object like this, okay, so here it will be have a certain velocity, and at highest point, at
Yes, sir. Yes, sir. Yes, sir. Understood. Understood.
Yes, sir. समझ गए.
Understand, sir.
Yes, sir. समझ गया, sir. समझ गया, sir.
okay, at
Sir,
highest,
at the highest point, the velocity becomes 0.
yeah,
Zero, sir.
okay. After this, now once again, this is going to be downward. Now velocity will increase in this case. Velocity
Yes,
Yes,
sir.
sir. Yes, sir.
will increase.
Because the acceleration is downward.
Yeah, now you can see the here the acceleration will be negative, and here the acceleration will be your positive. And
Still.
one thing you can understand. So
Yes, sir. Yes, sir.
you can see the acceleration is going to be constant. Means the graph will be for the uniform velocity. Okay, and the slope will be greater than 90 for this case. So the graph will be like this. This is your velocity, and this is your time, and you will have a certain velocity over here. So this is the case. So this will be straight line actually. So this is the first case. Time t, it will reach to the ground. Here the velocity will become equal to 0. Here the velocity is equal to u. Now it will come back to the ground, and the graph will be like this. Okay. So
Yes, sir. Yes, sir. समझ गया.
Yes, sir.
here you can mention it. A is equal to minus g, and here A is equal to plus g.
Plus G.
Okay.
Up. No, sir.
Pardon? So what we can write here, this is graph for body going upward. Body going upward. And this is graph for body going downward. Is it clear?
अगर ड्रॉप के केस में बनाना होता ग्राफ तो उसका कैसे बनता?
We are coming very soon. Okay. So now we should discuss one more point. If I am saying draw the acceleration time graph for the same process, if I am saying that draw the acceleration time graph for this graph, so how you will draw?
Sir,
Acceleration time graph for this process. How it can be drawn? Let me know.
The
Yeah.
triangle.
Yeah, no, I'm talking about the acceleration time graph. You know
so
that,
it will be a straight line.
but here the straight line will be your, it will be this. You can draw here. We can use the different color pen. Okay, wait for a minute. And this is the case. Look here. The for this part up to here, the acceleration is going to be negative now. So it will be your
Yes, sir.
negative acceleration. This is your acceleration, and this is your time. And after this, the acceleration will become positive. What my point or not? You can see now. I have written.
Yes,
This is a is equal to minus g up to the this point, and a is equal to plus g after this time. Got it?
Yes, sir.
Okay. So the next page. I think.
Yes, sir.
Yes, sir.
I think people have some network problem. He's not saying anything.
No, sir. Clear, sir.
Okay. Coming to the next.
I never face network problem.
Okay. Coming to the next is if a ball is dropped from certain height, and it rebounds after striking the surface. After rebounds after striking surface. Plot BT graph.
Sir, same as previous, sir. V.
No.
That triangle, sir.
No, it will be not like previous. You have to just be careful. Aryan, be careful while solving this type of question. You should think, na?
Yes, sir.
Sir, first acceleration will increase. After that, it will get retarded.
Acceleration is going to be constant. Yeah, this will be the graph, but acceleration is going to be constant.
Yes, sir. Acceleration will be constant.
Please remove it.
Sir,
Okay,
velocity will increase and decrease.
Yeah, you can see in the first case, I can use the different color here. In the first case, if I'm saying ball is dropped from certain height, so it means what? This is the height h is there, and ball is dropped from here. It will be zero. Now, what will be the initial velocity? It will be zero as ball is moving downward. So velocity is going to increase. Velocity increases, and acceleration due to gravity is along the direction of velocity,
Constant.
positive and constant. And once it reaches to the ground, it rebounds. So if it rebounds, it means what? If it rebounds, then now the velocity is going to increase. In this case,
Velocity decreases.
Decrease.
Acceleration equals to minus g.
yeah, and the acceleration will be equal to minus of g. So for this case, this is t. When it reaches at the ground, this is your velocity. Here the acceleration will be your positive, and here the acceleration will be your negative.
Negative.
Okay, so you got my point?
Sir,
Yeah.
Yes, sir.
Acceleration type graph बना है, sir.
Yeah, acceleration time graph will be the inverse of the previous one.
Yes, sir.
So it will be
First,
like,
तो पहले ऊपर होगा फिर नीचे.
हाइट से गिरेगा ना सर?
yeah,
सर,
yeah.
सर बॉल हाइट से गिरेगा ना सर?
But बच्चे, we are talking about the velocity. So velocity will be zero from certain height, na? Okay. So people used to get.
इसका पोजीशन टाइम ग्राफ कैसे बनेगा?
Yes, we can talk for that. Okay, coming. Let's see first. So in this case, this will be this, and here it will be negative. Okay. So this is your acceleration time graph for this. If you are talking about the means position time graph, now you can see this graph, and you can think. What you can think? You are seeing that the velocity is continuously increasing. Now, velocity is continuously increasing. So if you are
Yes,
talking
sir.
position time graph, it will be like this. This is the case, na? Not very straight, but it will be like this.
Yes, sir.
It will be parabolic, na? So it is something, means you are just dropping. For dropping, what will be height? H is equal to half gt square. The initial velocity is 0. So this is going to be constant.
Velocity is increasing uniform.
Yeah,
This position is increasing uniformly.
not uniformly, which is h proportional to the t square. H proportional to t square. This is a parabolic graph. Okay. So this is
Yes, sir.
for the when it reaches at the ground, it will have a maximum velocity. Okay. Now
Yes,
the
sir.
velocity is going to decrease non-uniformly. Means the position is going to decrease non-uniformly. Okay. If you are talking about the position or something like this, the time is going to increase. Okay. This is the case for this case. This is the graph for this part only. Now you are saying that it is rebounding. So if it is rebounding, sometimes the graph can be understood in this way, like this. Okay. So in this case, it is going downward. In this case, it is going upward, and when it reaches to the maximum height, if you are saying that if you are talking about the position, you can sometimes it is also drawn like this. Wait for a minute. Sometimes it is also drawn like this, because you are saying that the position, you can see now the position is, if you are talking about the displacement, then it will be like this. Okay. If you are talking about what, you are talking about the position, that is for the distance, it is for the displacement, but for the distance you can see like this. You can have graph like this. From here you can see now the position was just going to increase, means this was the case for this. Okay. Okay, this was the case. And in this case, in the second case, if you are saying that A is negative, then if you are talking to the distance time graph, so distance will be increasing, but the velocity will be decreasing. So what happened in this case? Have you remember this one? So this can further drop from here. This can be the graph. Okay, and the time will come when slope will be 0, then it will stop. So this is a case for the distance time graph. And the another was which I draw earlier, that was the displacement time. Okay, got my point or not? Not yet.
Yes, sir.
Okay. Should we move ahead?
Yes, sir.
Okay, coming to the next page.
Yes, sir.
Coming to the next page and coming to the question. Okay, so we are going to solve certain questions. So the first question which I am taking, that is from the item. What is that question? Let me first type and see the question. So first question I am saying that it is related with your car and means, let's say talk about the train. Okay. So the question is, two parallel rail tracks run north and south. So you need to just draw like this. This is north, and this is south. This is your east, and this is your west. Okay. So they are saying two parallel rail tracks run north south. Two parallel tracks. We can make like this, north south, and the given train A moves with north with speed. Train A moves. This is let's say train A, BA, and the velocity of this is basically 54 kilometer per hour. 54 kilometer per hour. And in another case, train B moves south. Now the train B, here is the train B, which is moving in south direction, and the speed is once again, this is 90 kilometer per hour. Whenever they are saying the speed, okay, whenever they are saying that the speed is this much and all those things, so it will be always taken with respect to the ground. Okay, it is always taken with respect to the ground. Now the question is relative velocity of B with respect to A. Find. First is relative velocity of B with respect to A. So this
36 kilometer per
the
hour.
second case, relative velocity of ground with respect to B. Relative velocity of ground with respect to, don't write to B. In third case, what they are asking, if they are saying velocity of monkey running on the roof of the train A, they are saying, what they are saying, let's see here, velocity of a monkey, what you have to find, velocity of monkey, velocity of monkey running on roof, running on roof of train A against the motion with velocity. So what is the basically velocity? With velocity 18 kilometer per hour with respect to train A. As observed by man standing on ground. Man standing on ground. So you can see, let's see the question part by part. So in first case, what they are asking, velocity of B with respect to A. Okay, you can easily do this question. You can easily do this question. How you can do this question? So you know about the relative velocity. How to find out the relative velocity? Let's come to the solution of first part. You can assume in the means you can say that this velocity of A you are taking positive, means you can assume like this. In this direction we are going to take positive, and in this direction we are going to take the negative. Okay, so first you should convert this 15 kilometer per hour in meter per second. Okay, you should convert 15 kilometer hour in meter per second, and you should also convert this 90 kilometer per hour in meter per second. So how you can do this? So it can
By
be,
multiplying 5 upon 18.
yeah, exactly. 54 can be written as 5 by 18. So this will become meter per second. So how much it will become? 18 3 is a 54.
15 meter per second.
Yeah, it will become 15 meter per second. And what
Per
about
second.
it will be your, I'm writing directly 25 meter per second. Okay. So what you can see, they are asking relative velocity of B with respect to A. they are saying velocity of B with respect to A. What they are saying? Velocity of B, this is the case, velocity of B with respect to A. So you are seeing that velocity B you have taken as a negative. So you will write here minus VB and minus VA. So it will come how much? It will be your minus 25 minus 15. So how much it will be? Let me know. Minus 15 meter per second.
10.
Okay,
Minus 40.
isn't it?
Yes, sir.
So this is a velocity of B with respect to A. Now in the second case, they are asking relative velocity of ground with respect to B. So in this case, what you need to write, velocity of B with respect to ground is equal to velocity of B minus velocity of ground. Okay? You need to write like this. Okay? So actually the time is just going to over. So we'll connect tomorrow and we'll start from here only. Okay?
Yes,
Okay,
sir.
sir.
Yes, sir.
Okay, sir.
Thank you, sir.
Bye,
Okay,
sir.
sir.
Bye, sir.
Bye, sir.
Bye, sir.
Bye, sir. Bye, sir.
Bye,
Thank you,
sir.
sir.
Bye, sir. Bye, sir.